Hello, my name is Herman, and today we'll be going over compute and order real numbers with the calculator. So today we're going to be simplifying square roots when possible and estimating the integers that aren't perfect squares. So here we're going to have numerous examples, which we're going to leave up to you to solve a couple of them. So then on the first example we have 1 over the square root of 4 is equal to 1 over 2. Now if you see here in the middle where I'm circling, this is the square. Redo. So here in the middle we have the square root of 4, which is equal to 2, which this table you can use to solve these. We can simplify this fraction into 1 over the square root of 2 is equal to 2. So then now we know that these are equal to each other, so this is true. Now we have 1 over the square root of 1, and again if you see the table here, you can see the square root of 1 is 1. So we can just simplify this to 1 over 1, and we see that this is greater than 1/2, so this is correct. So then our last one that we're going to do on this side is 1 over the square root of 9 is less than 1/2. So if you see again the table here, we can simplify the square root of 9 to 3. So we have the square root of 9 turns into 3, and then it's less than 1/2, which is true. Now these three, we recommend that you work them out yourselves, and you can use the table right here in the middle as I did to help you out if you're having trouble. So now we're only going to do 2 on this side, which are going to be these, and the rest are up to you. So the first one is, we're going to be simplifying, is the square root of 4 over 2 is equal to 1 over 1, and it's greater than the square root of 3 over 2. So since the square root of 4 is a perfect square, it's easy to convert to 2, or solve to 2, and it's going to be over 2, and it's equal to 1 over 1, which this just simplifies to 1, these two. So then we have is greater than the square root of 3. Now since 3 isn't a perfect square, we can use this table right here to estimate where it falls on the number line. So the square root of 3 falls between the square root of 4 and the square root of 1, which are perfect squares. So we know that the square root of 3 falls between 2 and 1, but since the square root of 3 is closer to the square root of 4, we know that it's going to be closer to 2 than it is to 1. So we can just estimate that it's about 1.7. And then it's over 2. So using this, we can tell that this is true, that 2 over 2, which converts into 1, is equal to 1 over 1, which simplifies to 1, and that is greater than 1.7 over 2. So now we're going to move to the third example here, and the second one and fourth one y'all can work out yourselves. So now we have the square root of 36, which we can see here is equal to 6 over 3, which we're just going to leave as 2 to simplify, and then that's equal to 2 over 1, which again we're just going to leave as 2. And then we have the square root of 12 over 2. Now again, this isn't a perfect square as we had in the previous problem, so we're going to estimate again. So we know that the square root of 12 falls between the square root of 16 and the square root of 9. So that means that the square root of 12, when you solve it out, the number is between 4 and 3. And since it's going to be closer to 4 than it is to 3, or actually it's going to be closer to 9 than it is to 16, we can estimate that it's going to be about 3.4 or 5, around there, if we round, and then that is over 2. So again, we know that when we simplify this, we can tell that this statement is true because 2 is equal to 2, and 2 is greater than 3.5 over 2. Thank you for watching this video tutorial, and keep on learning.